We can imagine having a colloidal particle in some sort of liquid, and the particle could be moving relative to the solution. Or we can imagine having some sort of tube, like a capillary made of some sort of solid, and having a liquid move through it. In either case, we're going to have a charged surface on our solid, if we have a non-zero surface potential, and a liquid's going to be moving relative to it. We're going to find in every case that there's a relationship between how fast the particles are moving and a voltage. We can split the four phenomena we're about to study into categories based on what's moving, what's being applied, and then giving that effect in a name. So first, what's applied? We can imagine applying an E field. And having that E field move a colloidal particle. This is called electrophoresis. On the other hand, we can imagine taking an electric field and actually moving the liquid. This is called Electro-Osmosis. We can imagine applying gravity to a colloid and having the particles either sediment if they're heavier than the liquid, or cream, that is, rise to the surface if they're less dense than the liquid. So in this case, what's moving is the colloidal particle. The effect is called sedimentation potential. We can imagine forcing liquid to go through a capillary with pressure. So what's moving is the liquid again. And we find that we can generate a potential called streaming potential. So notice in the first two effects, electrophoresis and electro-osmosis, we're causing something to move by applying a potential difference across a length, in other words, using an electric field. So an applied electric field generates movement. In the other two effects, we're using something else to cause the movement, whether it be gravity and the density difference, or just pressure across through a tube, a pressure difference across a tube, to cause things to move, and that's going to generate a potential difference. All of these things are called electrokinetic phenomena. We're going to discuss these in detail over the next few screencasts.